This is Professor Pelton. This is Trigonometry Chapter 2, Section 3 on inverse trigonometric functions. We're going to start off with, this is part 1 of 2. We're going to start with the inverse sine, then cosine, then tangent. So remember back for inverses. Let's say I have a basic algebra y equals 2x plus 3 linear function. If I want the inverse, all I have to do is switch the variables. So the inverse would be x equals 2y plus 3. However, not all functions have inverses, so there's a variety of ways you decide on inverses in algebra. We're just going to remember back to the horizontal line test. Basically, if the horizontal line can be drawn through a function such that it passes through more than one point, it is not going to have an inverse. That's a function. So if I look at this horizontal line drawn here, it clearly goes through more than one time, so therefore sine does not have an inverse as a result. So we're going to work around that. What we're going to do is we're going to limit our domain of the sine from negative pi over 2 to pi over 2. So as a result, we're ignoring the rest of the sine function, which goes on forever, and the remaining piece will actually pass the horizontal line test if I limit it to negative pi over 2 to pi over 2. Okay. So the resulting graphs, my regular sine will be limited to negative pi over 2 to pi over 2, which limits my range, so that's the limit of the domain here, right, left to right, which limits my range of the inverse sine function. And the inverse sine function would normally go all the way forever if I hadn't limited it, which would not be a function because it would fail the vertical line test. But since we limited it, it will actually work. And we use this notation to represent the inverse, because typically you'd switch the variables. So I would have x equals sine of y for the inverse, and this would be the original here. However, this doesn't work because it goes on forever, so we use this notation here with a -1 to signify that special inverse. So likewise on the graph, I've highlighted the part that's actually in the domain. So if I actually switched it, it would go forever, which is not good. We don't want that to go forever. Okay, we limited it. So if I actually use the proper notation with a -1, the calculator will know to limit it to the appropriate range of values. And much the same for cosine and tangent, but they'll change slightly. We'll discuss that in later pages. Let's do some examples. Okay, so first example, I have an inverse of a common ratio you've seen in the past. So what this is actually asking us is, what angle is this based on an inverse of root 2 over 2? Well, if I work backwards, I'll do sine to both sides. And the reason I'll do sine to both sides is what cancels sine inverse is sine. They're inverse functions. So that cancels that, which is basically asking me, when does sine equal root 2 over 2? Well, if I think about it, I draw the unit circle. Where is sine positive? Well, sine is positive in this quadrant, and sine is also positive in this quadrant. Okay, so I need, where is it root 2 over 2? Well, it's root 2 over 2 here and here for pi over 4, and another pi over 4 here, which is really 3 pi over 4 if I went all the way over. However, here's the problem. This is inverse sine, which makes this easier because inverse sine is only good from pi over 2 to negative pi over 2, which is only on quadrants 1 and 4. Therefore, I could not be in that quadrant. Thus, this coordinate right here is root 2 over 2, root 2 over 2, which is cosine sine. So it had to have been the pi over 4 answer. So the answer is a positive pi over 4 since we're in the first quadrant. Pause the video, try the second problem. Okay, next one. Again, we're asking for what angle does the inverse of root 3 over 2 give us? Okay. Okay, well, if we work backwards, this will be the last time we do this. We'll stop doing the written out part after. So that cancels. So we're asking us, when does sine of an angle equal root 3 over 2? Well, again, my choices for a positive sine are as follows. The first quadrant or the second quadrant, but I can't be in the second quadrant because sine inverse has to be in these quadrants here between pi over 2 and negative pi over 2. I had to have swung that way, or I had to have swung that way. That's my only choices. Well, if I'm root 3 over 2, that's going to give me a coordinate of 1/2 root 3 over 2, which is a 60-degree angle, which is pi over 3 to get there. So in this case, my angle is pi over 3 to get that ratio. Okay, let's try the next problem. Alright, so now we're going to stop writing out the algebra to work backwards. We're just knowing now that we're asking is, what is the angle such that the inverse is negative 1/2? Well, again, if we draw our unit circle, again, you'll need to draw the unit circle either. This is just for reference for the lesson. I have to be between these two axes because I have to be between pi over 2 and negative pi over 2. Well, in order for me to be negative, I have to be in the fourth quadrant for sine, because this is the positive negative quadrant, so sine is negative there. Well, that's going to be this angle here. I guess it's a little more of a pitch there, I guess. I didn't draw that quite well. Maybe that's too much. I'm not sure. Yeah, it probably is. That's okay, though. So root 3 over 2, comma 1/2. But it's negative for the y value for cosine sine. And that is just a 30-degree angle of pi over 6. But I went this way, so I have to be negative. So my angle here is negative pi over 6. Alright, let's try the next one. Pause the video, try a student problem. Alright, so again, we want to know the angle such that I get a pi over 2 but negative. And I have to be between pi over 2 and negative pi over 2. So I cannot be these two quadrants. I have to be in the first or fourth. Well, in order to be a negative pi over 2, I had to have gone this way. And the angle that gives me that is this coordinate created by negative pi over 4, because I went in the clockwise direction. So theta is negative pi over 4 to get to the coordinate that gives me the negative answer. Okay, that's the end of sine. Let's try cosine on the next page. Similarly with cosine, it's not going to pass the horizontal line test no matter which one you draw. Assuming it's within the 1 to -1 range, it's always going to fail the horizontal line test. So again, we need to limit the domain to 0 to pi, which is different than the sine. The sine is negative half pi to half pi, but here it's going to be 0 to pi, and you can see why. Because if I did the halves, it would fail the horizontal line test miserably. So if I do 0 to pi, now what's left of the cosine will in fact pass the horizontal line test. So it will have an inverse. Okay. So likewise, limit the cosine to 0 to pi. So that limits the range of inverse cosine from 0 to pi. And we're going to use the special notation of the -1 again, because if I did x equals cosine of y, that would keep going forever, and that would fail the vertical line test and not be a function. Okay, let's try some problems. Alright, so again, I'm not going to write out the full longhand, but we're asking ourselves basically, for what angle does the inverse equal negative root 3 over 2? Well, if we do our unit circle, we have to ask ourselves, where is cosine negative? Well, this is the negative positive quadrant, this is the negative negative quadrant. Cosine sine, cosine sine. So clearly it's 3 and 4. However, we have to be between 0 in pi for inverse cosine. Therefore, I cannot be this quadrant. Also can't be this one, but that wasn't really in the cards because we want to be a negative answer here. All right. So we want a negative root 3 over 2 for the cosine. So that's a negative root 3 over 2 comma 1/2 for the cosine sine, which is an angle of pi over 6 for the reference angle, which is a 30-degree angle. However, we're coming from this axis over here, so that's 5 pi over 6 to get the actual angle to get there. So my angle is 5 pi over 6 to get the negative root 3 over 2 for inverse cosine. Alright, pause the video and try the next one. Okay, cosine of negative 1/2. So again, we're asking an angle such that the inverse of cosine is negative 1/2. If we look at our coordinate plane, since I have to be between 0 and pi, I can't be these quadrants. That only leaves this quadrant over here, because that'll give me a negative 1/2 comma root 3 over 2. So that'll give me my answer, which is going to be a pi over 3 since it's a 60-degree angle. But I have to get there from here, so that's going to add another 2 pi over 3 for a total of pi. So it took me 2 pi over 3 to get there. So my angle is 2 pi over 3 to get the inverse of cosine, getting negative 1/2. Okay, we'll just finish off with tangent now. Okay, tangent's a little bit different because we don't need to cut it off, but essentially it still fails the horizontal line test. But what's nice is we're going to limit it to one cycle. That's it, which happens to be the same domain as sine. So sine and tangent go together, and cosine's kind of the oddball out. But cosine was also the oddball out in the odd-even functions. Okay, so you notice now if we just do one cycle, it passes the horizontal line test. All right, so in conclusion, one cycle has a domain of negative pi over 2 to pi over 2. So one range now is negative pi over 2 to pi over 2 for the inverse, which passes the vertical line test. Therefore, it is a function. And again, likewise, we're still using the special notation for tangent. Okay, let's try some problems. So we're asking ourselves, for what angle does the inverse tangent give me root 3 over 1? And I change it to that so we can see the ratio. Well, it's tangent positive, so if we make our unit circle, tangent is positive here, and tangent is positive here, because essentially tangent is sine over cosine from the identities. Well, here's the problem. I have to be between pi over 2 and negative pi over 2. Therefore, I cannot be these quadrants here. I have to be over here in 1 and 4. And I have to be a positive answer, so therefore I can't be down here because that's negative, because I have to be here. So therefore I have to be in this quadrant here. So I need a coordinate of 1/2 root 3 over 2, which is my cosine sine. So if I actually plug that in, that would give me root 3 over 2 over 1/2, which would cancel, give me root 3 over 1. So the question is, what is that angle? Well, if I have cosine 1/2 and sine root 3 over 2, that's going to be a 60-degree angle, correct? So that's a pi over 3. So my theta is pi over 3. Okay, pause the video, try the student problem. Okay, so the student problem is basically asking you is what angle is the inverse tangent going to be a negative 1 over 1? So we think of our unit circle. Tangent inverse is limited to between pi over 2 and negative pi over 2. So in order to get a negative, I had to have gone down in this quadrant here, because positive positive is not going to work, but positive negative will work. So this had to be the root 2 over 2, root 2 over 2, negative, for the pi over 4. Because again, if I do the sine over cosine, that would give me negative root 2 over 2 over root 2 over 2, which is negative 1 over 1, because anything over itself is 1. Okay, but I had to have gone clockwise, so that's going to be a negative angle as a result. That is the end of part 1.